Thank you for attending this practical theoretical practical class. Actually, I will today discuss the theory and procedure, and in the I think when you will be coming to our institute by 21st March, then of this year, then we can uh, show you the practical demonstrations. Right. So today I will just discuss you the basic questions I will discuss, and I will send you the assignments. That is, today I will discuss partition coefficient of, you can write, can you hear me? Hello?
Yes, sir.
So I will present something, uh, actually the title of the experiment. Actually I have already have that slide, but anyhow I missed that. So I have to prepare again. Okay. So I'll present something. Okay. 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 So the subject, do you know subject code that I already given to you? What is that? H1171. Chemistry laboratory. Actually, I'll discuss two experiments. Another teacher will contribute other experiments. Okay. Now, what is the title of the experiment one? That from my part, experiment one, you write down the title, determination of partition coefficient. Determination of partition coefficient of, okay, determination of partition coefficient of benzoic acid. Benzoic acid in toluene. This is another solvent. Toluene and water. Actually, toluene and water, these are the two solvents, and benzoic acid is the solute. Right. So, number one, solute. What are the solute here? It is benzoic acid. C6H5 3 Okay. Now, what are the solvents for the present study? Solvents means toluene and water. Now, if I ask you that, I think you have the idea of benzoic acid. In water, in aqueous phase, in aqueous medium, that is in water, how we can represent benzoic acid? Can we write in this form? If I write more explicitly, that is it is a weak acid, so equilibrium towards right to the leftmost side, that is undissociated form. So it will ionize partly in this form, CO2 minus benzoate ion plus hydronium ion, H3O plus. You know this. So in aqueous medium, benzoic acid itself ionizes like this, but not fully, only a part, because benzoic acid is a weak acid. It is a weak acid. So partly ionized. But if I put benzoic acid in toluene, then what would happen? Can you guess? In toluene? That's what I'm asking. In the toluene solvent, in toluene, how do you guess what should be the nature of dissociation or any association of benzoic acid? Can you guess? Or do you have any idea?
Sir, I think it dimerizes.
Yes, you are right. Absolutely right. So benzoic acid in this solvent, that is toluene, it dimerizes to form the dimer like this. Again, this equilibrium is there. Now the question is, what is the structure, or what is the mechanism that this benzoic acid can form a dimer? Do you have any idea? You know that benzoic acid, how it forms the dimer?
Sir, hydrogen bond?
Yes, intermolecular hydrogen bonding. You are right. So this is intermolecular hydrogen bonding. By this way, the dimer form exists. Right. So benzoic acid in toluene, it may remain also in dimeric form as well as monomeric form. Now, the definition of the partition coefficient, what is that? Right. What is the definition of partition coefficient? What is the definition of partition coefficient? You can write when a solute, right? When a solute is added, when a solute is added in a mixture, of two immiscible solvents. So then the solute, say here benzoic acid, then the solute would distribute itself in these two solvents. In these two solvents in such a way that the ratio of the concentration, the ratio of concentrations of the solute ratio of concentration of the solute in these two solvents, in these two solvents will be constant, will be constant at constant temperature. That means at a given temperature, the ratio of the concentration of the solute in these two solvents will be constant, provided, this is very important criteria, provided the solute is or remains in the is it clear? When a solute is added in a mixture of two immiscible solvents, then the solute would distribute itself in these two solvents in such a way that the ratio of concentration of the solute in these two solvents will be constant at constant temperature, provided the solute remains in the provided the solute remains okay. provided the solute remains in the same state, of aggregation, aggregation in both the solvents, in sorry, in both the solvents. This constant is known as this constant is known as partition coefficient. Okay, right. Suppose we have concentration of water and toluene is there, say for the present case, right? Where benzoic acid is the solute, right? So for the present case, what you have noted, benzoic acid, right, remains as the dimer, in the toluene layer, and monomer and monomer in the aqueous layer. Therefore, in this case, the ratio CW, concentration of benzoic acid in water, by square root of concentration of benzoic acid in toluene layer T will be a constant quantity, at constant, right. Now if you need any clarification, okay, I just discussed already that benzoic acid is such a species, such a molecular species, which remains mostly dimeric form or predominantly dimer form, in this case dimer form in toluene layer, that is non-aqueous medium. Whereas in aqueous medium, that is in water, it ionizes partly as benzoytine and the corresponding hydronium ion. But this dissociation or ionization, whatever you can say, is very weak. Okay. Now the question, how this factor square root of that in the solvent where the concentration Ct, why we put the square root, right? That is the question. Now I ask you one thing, why the two liquids, toluene and water, these two solvents are immiscible? Can you explain?
So one is polar and another is non-polar.
But you should quantify the polarity by a physical quantity. Do you know that?
So dielectric constant, sir.
Yes, yes, you are right. দেখো তো একটা ক্লাসে আছি পরে করছি। হ্যাঁ 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 okay, okay, হ্যাঁ না বলো না এই জানি তো হ্যাঁ হ্যাঁ জানি তো জানি জিনিসটা কোথায় হচ্ছে আমার তো মনে হয় একসঙ্গে গেলেই ভালো হতো কমিটি না ওয়ারেন্ট কিছু নেই হ্যাঁ সেটা করতে হবে ওদের পাওয়ার আছে ডকুমেন্ট তো হচ্ছে এটাতেই ফাঁসলাম এই একটাতেই ফাঁসলাম ঠিক আছে ওকে So water and chlorine, these two are immiscible because you are right, the dielectric constant of water is about 80 and that of chlorine or benzene like that, it is around very small, around 2.0, which I mentioned this quantity. Actually what happens, suppose two ions are there, say arbitrary, N plus and A minus, right? Suppose these are ionized ions. Now, which solvent? The solvent has a significant role to ionize these, right? Now, the question is, what is that role? You know, oppositely charged ions, they interact, force of attraction. What is that? Uni charge. So it would be, what is that? If the distance between them be, say, r, arbitrary, then we can write, what we can write? Minus 1 unit charge. So E minus E into plus E, so it would be minus E square by R, right? Force of attraction, it would be R square. You know this. And there is a factor in the denominator that we call dielectric constant. Now from this it is clear to you the attractive interaction between two oppositely pole ions or charges. This is crucial. And if the dielectric constant is very large, say for example in aqueous medium it is significantly large, which is about 80, so the force of attraction between these two ions, M plus and A minus, would be much small. But if D is very small, as in the case of toluene, say for toluene, the D value is dielectric constant, which is about 2 approximately. But in aqueous medium water, it is about 78 point something like that. So from this, it is clear that why in aqueous medium it ionizes significantly, while in non-aqueous medium it remains mostly not in the ionic form, but rather in the undissociated or diameric form. Clear? So one cannot expect ionization at all in toluene layer or any non-aqueous medium where the magnitude of this dielectric constant is very small. Right. So that's why the two layers are immiscible. Now my next question, suppose in a bottle, if you take two liquids, then which liquid would be at the lower side and which liquid will be in the upper side?
Denser will be lower.
Do you have any idea? You should have some idea. The water, another liquid is,
Density
say,
factor.
yes, so density of water is much larger, right? So water would be in the below of this intersurfacial region. Here it would be, say, tolerant, H5, because it is lighter, it will float on the top of water. Right. Even if you say after some time, you can identify this junction here. A demarcation sign means you can visualize the separation, the boundary of the two layers. Why? This is my further question. Why the boundary region is sharply visible for these two liquids? Can you guess? And what is that? How can you explain that? By which physical quantity you can explain that? Yes. Anybody else?
The boiling point.
Not boiling point. It is the refractive index. Right. Refractive indices. Due to the difference in the refractive indices of the two liquids, their boundary is clearly visible. Right. This boundary region is visible clearly, and which is due to the difference in the refractive indices of the two layers. Right. I cannot remember what is the magnitude of refractive index of water or toluene. You can get it from the website. So difference of this refractive index plays a significant role to identify the boundary region of the two layers. That is water and benzene, toluene and aqueous layer, water. Now the next question, why we put this constant instead of Cw by Ct? Why we are writing Cw, concentration of benzoic acid in water, divided by concentration of toluene, concentration of benzoic acid in toluene layer. Right. Now that you should write also. What is Cw? Denotes concentration of benzoic acid in water or aqueous phase, and Ct denotes concentration of benzoic acid in both cases. It is the monomeric form. We are calling benzoic acid in toluene. Okay, so both cases we are considering comparing concentration of monomer. Right. Comparing concentration of monomer form of benzoic acid. Now this question I'll discuss. Why this square root appears? Right, that we discuss. Now meanwhile, if you have any query or any question, please feel free to ask why it so happens, why What is the reason of writing this? Okay. If you have any doubts or any question, you can ask. Okay. Okay. Is it clear? Hello? Can you hear me?
Yes, sir,
Yes.
clear.
Is it right? Up to this, do you have any clarification? Okay. So let us
Yes, sir.
denote benzoic acid as B. Denotes benzoic acid. So we can write numeric form. We can write that B2 in non-aqueous medium, this dimer remains in equilibrium with the monomer. Okay. And let the concentration we denote, say, any arbitrary concentration, C into 1 minus, since normally we use alpha, here we use beta, that is extent of dissociation. So see the concentration naturally as per stoichiometric coefficient, it should be 2 beta. Why? See the total concentration of acid in benzene layer. What is C? C is the total concentration of benzoic acid, benzoic acid in chlorine. Okay. So what is the concentration of dimer? What is the concentration of monomer? It is clear. So what is the equilibrium constant? So right, the
आपण डायरी पर लिखते हाँ हम डालेगा लिखवा दे हाँ चल
equilibrium constant. Now what is the equilibrium constant? That I'm writing simply K, capital K, that you can write. How you can write? Is it clear to you? That is concentration of B at equilibrium to, sorry, it would be, okay, I'm just writing in terms of concentration, that would be better. 2 beta C. Okay. So we should write 2 beta C, and since is the concentration, and this is the 2 is stoichiometric coefficient, so we should write 2b C2 square. So we should not write this square bracket because these are the concentrations. Okay. So we should write clearly this whole square by the monomer concentration, that is C into 1 minus beta. And this on simplification, provided beta is very small, then naturally one can write, you can easily see 4 beta squared C, right? Provided beta is very small. So this is the expression, and you can write this equilibrium constant. So from this, simply can simplify easily. And can we write these expressions? Can we write this expression? What is beta? Beta equal to what we can write? Can we write square root of k by 2 square root of c? Yes. So you can write concentration of monomer benzoic acid, monomer of benzoic acid. What should be that? Concentration of monomer in toluene. Sorry, monomer of benzoic acid in, we are discussing toluene, right? In toluene. What is that? What can we write?
Under root C into K.
This is equal to 2 beta, and this is equal to, you can put the expression of this, 2 square root of k, beta equal to beta equal to, actually we obtain square root of k by 2 square root of c into c. So the expression appears to be k. Sorry. Yes. K. Yes. K. 2 cancels out. Square root of c. This is the expression of monomer concentration of benzoic acid equal to this.
Sir, K is inside the root.
Yes. 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 So you can put it k prime, where let k prime equal to square root of k. Now it's all like just write compact form. Now what is the concentration of benzoic acid in aqueous layer? Right? How you can write ionization? So you know this C6H5C. Okay, we are not writing this. Okay, we just writing B. It ionizes to benzoatine C6H5CO2 minus. I am writing compact form. You can put like this. Okay. Now this equilibrium, we can write this concentration. We can put this concentration, say C prime, right, into the dissociation as usual. We write C prime 1 minus alpha, which is equal to alpha C and alpha C. C prime, sorry. Then what is the equilibrium constant or ionization constant? Right? A. This we call ionization constant. So this we can write alpha squared C prime squared by C prime 1 minus alpha. And as usual, if alpha is very small, then it would be alpha squared C prime. Sorry, C prime. It would be Okay. Now, if you just put these expressions there, that is alpha, these expressions, that is the undissociated form, right? So these are the dissociated form. And what is the undissociated form? That is, if you compare the partition coefficient, sorry, if you compare the partition coefficient A, E, whatever you can write, equal to concentration in the first layer by concentration in and if you put these expressions, what is the concentration of monomer form in the uric acid, one can write these expressions. Simply C prime 1 minus alpha, right? C prime into 1 minus alpha, okay, by, okay, you can write in the reverse way because square root appears like this. So C prime into 1 minus alpha, and in the denominator you should write, what is that? Monomer concentration here, root over A prime square root of C, right? So what is C? C is the concentration, total concentration, right? So you can write these expressions, that is how the square root of C appears, because at a given temperature dissociation a constant, all these are constants. So you can write C prime by square root of C. So partition coefficient, that's why the expressions that we, if you use that expressions, that is C W and it is C T as we denoted the concentrations. Okay. So is it clear to you? Or any conclusion? Hello? Hello? Is it all right?
Yes, sir.
So I think,
Yes, sir, understood.
okay. So now I will just demonstrate the procedure. That procedure part I will send you by mail or Google Classroom. That would be better, right? That I can. So
Sir, we need to
I,
make the notes and submit in classroom, like assignment.
no. Okay, after I give the complete course, then you submit.
Okay,
Okay.
sir.
In the classroom, you will submit, but before that, I'll create a classroom and I will show you the experiments, or you can. Problem is that how you can write the data, you can fill up the data.
Yes,
That
sir,
is
the
the
data.
right. So you can also, I can show you the procedure. That it doesn't matter. Just write how to determine this procedure. What are the experimental data? That is procedure that I can dictate. No problem. Procedure. Number one, prepare 250 ml. Prepare 250 ml standard N by 10 oxalic acid. Okay. This is number. Now before that, okay, this is one. Now in the second, you have to prepare solutions of the following compositions. Following compositions. In 3 well stoppered bottles. Okay. So the table would be somewhat like this. Bottle number, one column. Saturated solution of benzoic acid in toluene. This is in volume in ml. Pure toluene in ml. And water you take in the bottle also. Water in ml. So this is the table heading. Now in bottle number 1, you take 30 ml saturated solution of benzoic acid in toluene and 0 ml no toluene and 100 ml water. Now in the next bottle number 2, you take 20 ml saturated solution of benzoic acid in toluene, that is 20 ml. Take 10 ml pure toluene and 100 ml water. So the total volume is 130. Again in bottle number 3, you fill up with this composition 10, 20, this is 100. Okay, so this is the. So you have to take 3 well stoppered bottles and fill up these solutions and set at least 2 hours. And after shaking, you level the bottles, and that is your group, means roll numbers of this section, and then level it and then put it in your self custody. The department will provide you where this solution will be kept by you, because in the next day only you have to titrate the solution or mixtures, not in the same day. It requires at least 2 days. Okay. Now, so this is procedure number 2, and the third part is standardize. Standardize supplied. That will be supplied to you. Supplied. NaOH is not primary standard, so it would be N by 10, which is approximate. N by 10 NaOH solution by standard oxalic acid solution that you prepared Now, using which indicator you can use? Uric acid.
So potassium permanganate.
The acid-base titration, how is potassium permanganate? It is oxidizing agent, na? Using phenolphthalein. As indicated. Okay. Next, fourth part of the procedure is titrate 25 ml of solution from atmosphere of say bottle one using standard NaOH solution. Determine CW by square root of CT. That you have to calculate. Sorry, titrate 25 ml of the solution and titrate also. I'm not repeating, sorry, something has been skipped. So some correction will be there, and titrate. Since the solution of chlorine layer is small, so we take titration, titrate 5 ml of chlorine layer of same bottle number 1. I'm not writing using phenolphthalein and the same thing. Okay, it is written there. So you have to determine that quantity, CW by CT. Okay. Now repeat this procedure. Repeat this procedure of titration for bottle number 2 and 3. Okay, that you can do and determine this ratio CW by square root of CT for bottle number 2 and 3. Okay, so this is the procedure and experimental data. Okay, that I will show you later. Okay, so this is the procedure actually. So the remaining part of the procedure, okay, I try to send it by email, but without data. Okay. So this is the procedure. And how to standardize, say, supplied NaOH, which is approximately 10 by 20, right, with oxalic acid. Can you guess how we can standardize? Hello? How to standardize? How to standardize using N by using supplied N by 10, sorry, N by 20 NaOH solution. Okay. So this is the procedure. You please go through it. And meanwhile, if you have any question in the next Wednesday, we'll again continue the class. Another experiment is there. So, okay. 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 So thank you all for attending this class, laboratory class.
Sir,
Yes.
sir, I want to ask you about the scenario of hostels. Like, should we book the tickets because the prices are increasing every day? So, if you have any idea on that, could you please tell something
Which one? Which one?
on reopening of college?
Regarding
Hostels scenario.
reopening, regarding reopening of college and hostels, I cannot give you any direction because you can see the institute website and there you can contact with the concerned persons in charge, studying student affairs and also warden.